So here are all the formulas for chapter 7 and the conditions. So for in 7.2 proportions, we know the mean of the sampling distribution. For proportions, the mean of the sampling distribution of p hats, if you keep taking many samples of p hat, is, and the notation is mean of p hat equals the true population proportion p. So there's one. And that doesn't matter if what the population distribution is. It doesn't even have to be normal. It doesn't matter. And then the standard deviation, of the sampling distribution of p hat is standard deviation of p hat equals square root of p times 1 minus p over n, and he used q, but the same as 1 minus p. This is given to you on your sheet, but you have to know that you have to test. In order for that formula to be true, it's as long as the 10% condition is true, as long as 10% condition true, meaning your sample size is not more than 1/10 of the total population. So as long as 10% condition true, meaning sample size n is less than equal to 1/10 of big N, your population size. So you have to state that somehow when you do the standard deviation only, not for the mean. And then on top of that, before doing any normal, if you're going to do a normal calculation only, then before performing normal calculations, where you use table A and the z-score, before performing normal calculations, you have to check the normal condition. Normal condition, which is this, that NP is greater than equal to 10, and both of these have to be true. N times 1 minus P is greater than equal to 10. So that's everything for 7.2 proportions. Those are all the formulas, the conditions for 7.2. And then how that changes for 7.3 for means. For means, means is very similar to proportions for the mean of the sampling distribution. So the mean of sampling distribution, I'll abbreviate a little bit. The mean of the sampling distribution of x bar is, the way you write it is mean of x bar equals the true population mean mu. So the average of the x bars will equal the true population mean mu. Mean x bar. And then standard deviation, as long as the 10% condition is true, you can say the standard deviation of sampling distribution of x bar. X bar is standard deviation of x bar equals the population standard deviation divided by the square root of n, and again, just like before, only as long as 10% condition true. So I won't write what the 10% condition is, but as long as 10% condition true for that. And then now for the normal calculations, you can do the same thing as you did before. Well, for means, before performing normal calculations, you have a couple of options because of the central limit theorem. So before performing normal calculations, you can check the normal condition, or for means only, you can use the central limit theorem, use the CLT, central limit theorem, and that says that no matter what the population distribution is, so if the population distribution, if you already know the population distribution is normal, then the sampling distribution will be normal, you're fine. But even if you don't know that the population distribution is normal, the sampling distribution will still be normal as long as your sample size is greater than equal to 30. So that would be using the central limit theorem. And I'll have a time for another video on that tomorrow as well. But sampling distribution will be normal regardless of the population distribution. Sampling distribution will be normal if sample size n greater than equal to 30. And that's just for means. So that should be everything you need for chapter 7. Formulas and conditions all together. And I'll put tomorrow's assignment on School Loop early in case you finish today's in class, and I'll give you your bios back tomorrow.